All right, everybody, welcome to the video for lesson number 9 and lesson number 11. So I decided to put both lessons in the same video here. So if you already checked lesson 9 or you didn't do lesson 9, you want to fast forward because you did 11, you can do that. All right. So in lesson number 9, we talked about the segments created by secants and tangents. So if we look at this first question, we have a secant-secant relationship. So the first thing I always want to do whenever I see secants and segments is try and find the outside part and the whole part, because I know I need that for my equation. So for the length from C to N, I know that that distance is going to be 8. I'm getting that distance by subtracting 20 and 12. For the other one, it's not so easy. So for the other one, I have x minus 27. The reason why it's x minus 27 is the whole length is x and the piece inside is 27. Just like what I did with the other one that just had numbers in it, I'm subtracting the whole minus the part inside. Now to find the equation, I'm going to take the segment of the outside and multiply it by the whole segment of the secant. That's for one secant. For the other secant, I'm going to do the same thing, x minus 27 times x. On the left-hand side, I get 160. On the right-hand side, if I distribute in my x, I get x squared minus 27x. Now, unlike the example we did in class, this one doesn't have x squared on both sides. So what we learned in algebra was whenever we see that, we want to subtract to get 0 on one side of the equation. And I don't want to try and factor. So when I'm factoring, I have to take into consideration the types of numbers that I have. So I want to try and find two numbers that multiply together to make 160, but add together to make 27. But notice the 160 is negative and the 27 is negative. So I have to kind of be careful here a little bit. So if I do some math here, I see that I can do 32 times 5. So I can make x minus 32 and x plus 5. Negative 32 and positive 5 multiply to make negative 160, but add to make negative 27. Then if I set both equations equal to 0, I get x equals 32, which is my answer. And I get x equals negative 5, which doesn't work for geometry, but I promise will work next year when you're in Algebra 2. For the second question, I don't even have to do this one again because we did it in class. This one in class came out to be 2 times the square root of 13, so I'm going to skip that one because you should have taken good notes in class today. The last one says that we have this situation, so we have a tangent and we have a secant. So let's start with the tangent. Whenever I see a tangent, since there's no internal part, it's multiplying itself by itself because the whole is the outside. It's the same thing. If we look at the other part, the outside part is 12 and the whole part is 27. I'm getting 27 by adding 15 and 12. As soon as I see x plus 8 squared, I know I have to do this whole box thing and multiply it all out. So I have x and 8. So x times x is x squared. X times 8 is 8x. Those two are going to add up to 16x. And 8 times 8 is 64. So I'm going to get x squared plus 16x plus 64 is equal to whatever 12 times 27 is. So if we do 12 times 27, I get 324. Again, I see the same situation, so I want to get 0. That's the important part here. So I'm going to subtract 324 from both sides. So I have x squared plus 16x, and then I get negative 259. Now, to solve the rest of this, we have to, again, try and factor. Sorry, I had a mistake there. It's actually 260, not 259. So again, we have to try and factor here. So I have this number 260 where I need to find two numbers that multiply to make 260, but add to make 16. So that's going to be positive 26 and negative 10. The positive 26 is again going to give me a negative answer, which we don't want. The other one, if we solve for x, we get x equals 10. If x equals 10, that means hg, which is x plus 8, is 18. Number 2 gives us a circle. We see a tangent, we see a secant. It tells us the secant is 12 inches long, and it says it's in a ratio of 1 to 3. Remember, ratios just mean variables. So if AC is 12, and the two parts of AC are x and 3x, I can say x plus 3x equals 12, or 4x equals 12, or x equals 3. Meaning the inside part is 9, the outside part is 3, and the whole part is 12. Now I don't know AB, and that's what I want to try and find, so I'll make that a variable. I've already used x in this problem, so I'll use y. I know tangent squared. Tangent squared is going to be equal to the outside part times the whole part. This isn't necessary to factor because it's just kind of an easy radical question or square root question. So I have y equals 6. The last question in this homework assignment gives us another circle. Notice there's a diameter drawn here. Diameters and radii that touch a tangent make a 90-degree angle. So just by looking at my picture, I know that. It tells us that CD is 2. It says DA is 6, meaning I know the length of this segment is 8. It wants us to find BC, so that I don't know, so that's x. So if I do x squared is equal to the part outside times the whole, I get x squared equals 16, which means x equals the square root of 16, or x equals 4. So now I know this distance from B to C is really 4. Then it wants to know the radius. Well, to find the radius, I could also find the diameter. I have two sides of a right triangle, so I could then find the diameter using Pythagorean theorem. So I'm going to make this side B, so I can say 4 squared plus B squared equals 8 squared. And then I can say 16 plus B squared equals 64, or B squared is equal to 64 minus 16, which is 48. So then B is equal to the square root of 48, which is going to be almost 7. So if we do the square root of 48, it becomes 6.928. But that's the diameter. To find the radius, I would have to divide that number by 2. I'll leave it right on my calculator to do that, and I would get 3.464. But notice it wants it in simplest radical form. So let's do that. So if I have the square root of 48, that breaks down to 16 and 3, which becomes 4 square roots of 3. That's the diameter. The radius is half of that, so that would be 2 square roots of 3. So kind of did it two different ways. It then wants you to find the measure of angle C. Notice angle C is an exterior angle in the picture, but we can find angle C. The reason why we can find angle C is because I know how to find a missing angle using triangles that are right triangles. So let's just redraw this right triangle for a minute. So we have a right triangle, the hypotenuse of 8, a side of 4, and an angle that we want to find. Now I know that this whole side is 4 radical 3, and that totally works, but I don't need to do anything with that 4 radical 3. I could just use the fact that this is adjacent and this is hypotenuse to use cosine of C. cosine of C is equal to 4 over 8. So now we can say C is equal to the inverse cosine, or the arc cosine, of 4 over 8. Or angle C is equal to whatever that comes out to be. So once you type that in the calculator, you get an angle here of 60 degrees. So now that we know that the angle is 60 degrees, we then can do some more math or some more geometry here. So it says to find the measure of AD, show how you arrived at your answer. So one of the things that I notice here in this picture is that we have a semicircle. So if I have a semicircle, I know that arc AB is 180. And because I have a tangent and secant situation, I can use this exterior angle to find arc DB. So I'm going to highlight what I'm talking about in red. So here's your secant, here's your tangent. I can find this arc by using this arc, because I know that arc is 180. So I'm going to make this x. So if I go through and do the math involved here, I know the exterior angle of any tangent-secant relationship is equal to half of the difference of the two arcs. Multiply both sides by 2 to get rid of the 1/2. So I have 120 is equal to 180 minus x. I then can say that I can subtract 120 from both sides and get negative 60 equals x, or negative x, or x equals 60. So I know this arc DB is 60. I don't want arc DB, I want arc AD. Well, arc AD is the supplement of 60 because they together make a semicircle, so it'd be 120. So there's your video for lesson number 9. Right, attached here will also be the video for lesson number 11.